This is going to be the first video on chapter 2 on the chapter in general is on variables, data type, constants, input, output, and arithmetic. Today we're just going to talk about variables and data type. So again, going back to Python, or in comparison to Python, C++ has some very different ideas about variables that we're going to talk about. So the first thing, what I'm showing on the screen right now is Warp on my Mac. So if you have a Mac and you have Warp, then this is certainly a program I would recommend. Note that you can always just use the terminal window, but we're going to use, for my examples, I'll use Warp. Okay. Notice that it has a command history, so I can go back up and do the SSH command that we've done before. Okay. You type in your password. Remember, your password does not show up as you're typing it. Okay. Again, all the messages you see here, you don't really need to worry about. I mean, we definitely need to install some security updates, but that's something for me, not something for you to have to worry about. So just ignore that. Okay. Remember, get in a habit. The first time that you connect into the server, whenever you connect into the server, so not the first time, every time you connect into the server, we have to change directory to our CSC 1100 or 1180 directory. Okay. That's the first thing to do. Okay. Then you can always do an LL that shows the files you there. See, I've been doing some things for examples. Okay. And then again, a PWD just guarantees that you are in the correct directory. Okay. So let's talk about how variables work in C++. So in Python, Python is what's called a loosely typed language, which means that I can just say, here's an integer. Well, let's do an example here. Let's we do like test.py for a Python file. I could just say, x equal 25. Yeah, then I could say, well, now I want x to be equal to 3.4. No, now I want x to be equal to a string. Okay. That's all perfectly legal in Python, but it doesn't work that way at all in C++. Again, one of the overriding differences between C++ and Python is the way it handles memory. And because C++ is very focused on how we can access and optimize the memory, it is going to require us to declare our variables in advance. We also have to choose what type those variables are going to be. So we have to know upfront whether it's going to be an integer or whatever. Okay, we'll talk about the types in a minute. Okay, so Python's a lot looser when it comes to that, and it will switch back and forth. Okay, so let's look at a program. We'll create a new one here. Let's call this variables or vars.cpp. Again, I'm using Emacs for that. I see the annotation. Can I make that go away? Because it seems to be in the way. Okay, not sure if that was in the way. I don't know how to make that go away. That's quite unfortunate. There we go. Now it went away. Okay, so that makes it hard to see my command line. If you're even seeing that, which maybe you're not. Anyway, so I'm going to create this new file called vars.cpp. We'll use this as another reinforcement of our basic files. Again, if you've copied the template file from last time, you can use that. Okay, so we're going to do an include iostream using namespace standard. Do our int main with our curly braces. Going to do our return 0. Okay. So when it comes to variable declarations, we typically, from a style point of view, although it's not necessary, we're going to put these all at the front. Okay, so I can put in a comment that says find your home keys, variable declarations or initializations, or inits for short. Okay, so in this section, I can go ahead and declare my variables. So if I do something like int for integer, integers are whole numbers, they have no decimal portions, x, semicolon. I'm now able to do things with X. I can give X a value. I can print out X. I can, use it in any way. Okay. So the only rule is that we have to declare a variable before we can use it. And variable names, I mean, they're very much like Python. They can't have any spaces. The capitalization is important. You can't start with anything but a letter, but you can include numbers later on. I could say x1, x2, and that's fine. You can do underscores if you want. Okay. When we initialize variables, we can't guarantee that the value is zero like you would like it to be. It used to be that it was never zero. It was just whatever happened to be left over in that memory spot. But nowadays with C++, it tends to be equal to zero. But if you want it to assume, or if you want to make sure that it's zero, it's always a good idea to go ahead and initialize the variable right when you're declaring it. Okay. That makes the most sense. Okay. So once we declare it, we can do something with it. Okay. So if you want to look at your variable options and what those ranges are, I've got another little chart here we can look at. Okay, so this is going to show the C++ data types that we have, the int that we just talked about. And to let you know, these numbers are based on our computer. These are pretty commonly what they are, but every computer operating system and compiler will take different amounts of space for variables of various types. Okay, so on our system, an integer can take the value from negative, what's that, 2 billion something to positive 2 billion something. Okay. If you need a number bigger than that, then you have to go. There are other integer types. There are longs and longs and all that, which we won't get to now because we won't need them for a while. Okay. And we have example on how to declare it, like I just did an example. Int miles equal to 245 is perfectly okay. Okay. The floats, they take up more room and they go from negative 3.4 times 10 to the 38th up to positive 3.4 times 10 to the 38. That's 10 with 38 zeros. Okay. And those allow for decimals. Okay. The floats, and you can look it up if you're ever curious, have a certain precision, how many variable or how many decimal places that they're accurate. The double is going to have more. Okay. And you see double is a bigger range. Okay. From negative 1.79 times 10 to the 308. So from 38 to 308 to 1.79 times 10 to the 308. Okay. So doubles take up more room, and they're more precise. So you would use them if you need that precision. If you don't, then a float's fine because a float's going to make a smaller program. Okay. In addition, we have chars, char. So a char is a single character, but when we talk about strings, which we will in a later chapter, um, chars are interesting and they're actually integers that point to characters. Okay, so we'll explain that later, but for now, just know they go from negative 127 to 127, and we declare a char with single quotes. Now in Python, we could use single or double quotes indiscriminately. For strings, you can't do that in C++. In C++, double quotes mean a string, single quotes mean a char every time. And chars can only contain one character. Okay. And then we have our Boolean variables. So a Boolean variable is going to hold a Boolean condition, which is true or false. We can either set them equal to true, all lowercase. I think in Python, true is a capital T, um, or false, the word false in all lowercase. In addition, zero gets the value of false. Anything else, but we usually say one, gets the value of true. Okay. There are other things that we use like their variable types, like as strings, but strings are kind of a special case that we can that we'll talk about later. Okay. So you just have to make sure that when you're doing variables, when you're using variables in C++, you initialize them first. And keep in mind, we'll talk more about memory later in the class, but when you store a variable in memory, it's going to take whatever size that variable is, okay? And it's going to reserve that for the variable that you have, okay? So again, unlike in math, a variable is not an unknown, okay? A variable is a label for a memory address, okay? It's a label that we're saying go to this spot in memory, okay, that the variable keeps track of, and tell me what's there, okay? One thing that we have to worry about, okay, and that's with integers. Go back to the server. Integers behave strangely in that if we get past that 2 billion number in the positive side, it wraps back around to the negatives, which is not a good thing, right? I think it's very inconsistent. I'm not sure why it does that. It doesn't flag an error or anything. It just does it. Okay. So eventually, when we get to checking our information more, we're going to have to make sure if we're doing any kind of addition or multiplication or whatever, to make sure that our numbers are not negative when we don't expect them to be. That means we've gone over how big they can be. Okay. So we didn't list strings as data type, but we certainly could do that if we want. We can say string is recognized here, equal double quotes, Bob, and that's perfectly okay. Okay. So strings, again, this is kind of a preview of coming attractions. The strings are more like a data type or a data structure than just a simple data type. But we can use them for now as a simple data type, and that's fine. And they behave pretty much as you would expect them to. Okay. So the next thing I want to talk about this video is the idea of typecasting. So in C++ in general, you have to declare a variable a type, and that's all you can do with it. But C++ allows, with restrictions, for you to convert from one variable type to another. Okay. There are two ways this happens. The first is called implicit typecasting. Okay. And it's also called type promotion. And this happens when the compiler will automatically convert a number of one type to another type for a calculation or whatever. Okay. As long as there's no possibility of data loss. Okay. So we don't have to worry about these. They just happen automatically. And this happens typically if you're going to take um, an integer and multiply it by a float, for example. Okay, so let's take a look at this. So let's say we have an integer x equals 5, and we have a float now y equals a, let's say. Okay, so no, that's how I want. Float equal x. That's how it makes sense. It's wrong in the book. That's exciting. Okay, so what we're saying here, x is an integer value, and we shouldn't be able to change it automatically to a float, right? But the compiler will say, okay, x is 5. I can convert x to 5.0, and we're going to be okay. Okay, and that's what you would do. So now x would have the value of 5.0. So it's an automatic or implicit typecasting of x from 5 to 5.0. Okay. The other thing we could do here, if we had the value of y being something else, like 2.4, let's say, okay, then if I would do something like the following, let's say we have a float called product is equal to x times y, okay? Strictly speaking, we can't multiply two variables of different types, okay? But because the integers contain no decimal points, we can assume that they don't have any and convert it to a point zero. And this would multiply 5 times 2.4 and give us the correct answer. Okay. It would not have to, um, we wouldn't have to do anything else. Okay. So those are the implicit conversions that just happen. Anytime we're dealing with floats and ints, it will convert the int to a float. Note that it can't convert a float to an int. If it would do so, then it would risk losing data of the decimal places. Okay. There's also explicit typecasting. That's when you particularly choose, the programmer chooses to make a variable a different type. Okay. So in this case, we could do something like this. We could say float y is equal. Okay. And I want to specifically and on purpose change the variable x to type float. Okay. I do this with the keyword static cast. So it's static cast. What I'm casting it to, in this case, it's a float. Okay. X. Okay. So this will guarantee that I have no loss uh, of data as I move back and forth. Okay. And we don't normally, we don't use this a lot, But there are times when typically if there's a function, a pre-built function that needs a specific data type, we can do a conversion like this if it doesn't do it implicitly. Okay. So, that's something we don't use a lot, but it's something to think about. Okay. And then the last thing we're going to cover in this video is the idea of constants. Okay. So constants in Python are interesting. I don't know about your Python class, but when I teach Python, I mention constants and we use the idea of constants. Okay. But in Python, there's no way to enforce it. So if we declare a variable in Python, um, whatever it may be, like max, okay, we can set it equal to whatever, 35. Okay. In Python, there's no way to enforce that. The all capital letters is program lore, program practice, whatever. When you're writing programs, when you see all uppercase, we all assume that it's a constant, even if it's not enforced. Okay. But there's no other mechanism to keep it from happening in Python. In C++, that's not the case. C++, if you declare a constant, you have to set a value when you're declaring it, of course, because it's constant, and you can't change it later or it gives an error. Okay. So, for example, if I'm writing a program that I want to keep the maximum number of students to be 50, I would normally do an int max students equal 50. Okay. That's a normal declaration, but I'm going to add the keyword const, lowercase const first. Okay. When you do this, it's now going to set, for this run of the program at least, max students equal to 50, and that can't change. Okay. So there's no way for it to change later. Okay. So that's an important thing to think about. So when do we use constants? Okay. A constant can be used for some kind of a bound on a program. Again, this max students makes some sense. If it's something we use throughout the program and you don't want the programmer or another programmer later to be able to change it, we'll use a constant. Okay. The other thing, or the other time that we use a constant, is to avoid what are called magic numbers. Magic numbers are numbers that appear in a calculation that we don't know where they come from. Okay. So let's take an example. And we haven't covered arithmetic yet, but I think you'll be able to figure out what we're talking about here. So I'm not going to declare the variables. Let's just say we know what they are here. But we've got some PV variable, which will be a float, is equal to future value, which is another variable, okay, divided by, we're taking a power function, again, we'll talk about later, which is an exponent, 1 plus 0.25, comma, periods, okay? So when you look at this formula, okay, if you know anything, if you had a business class, whatever, that's present value, that's future value, periods, how many periods are going to be for the loan or the investment or whatever it is. But what you wonder about is what about this 0.25? What is 0.25? In this instance, 0.25 is a magic number, right? We don't know what it is. Okay. So it's much better, but it's a literal right now. 0.25 is a literal that can't change. So we don't want it to be able to change. Okay. It turns out in this equation, this is the interest rate. So better to do something like this, where we're going to say constant double or float, depending on your precision. Okay, interest rate, putting a underscore between them, okay, equals 0.25. Okay. And then I can change this down here with interest rate. That was not what I wanted. Interest rate. Okay. So now when you're looking at this formula, you know that it's interest rate. Okay. And you could have made it, IR or something if you wanted, but this makes it even more clear. Okay. So the other advantage to this, we may be using this interest rate calculation throughout our program. Okay. If it's a financial calculation, you certainly could be. We use it all the time in this big long program. Okay. Interest rates have a habit of changing. So if we set early in our program a constant called interest rate with a value, and then consistently use that constant variable throughout our program, then if the interest rates change, all I have to do is change it up here. Let's change it to 0.2. Then I've automatically changed it everywhere in my program. If not, I would have to go through and search for every time I'm using 0.25, and it may not always be for our interest rates. Change all those manually. Okay. So it just makes sense from an organizational point of view for us to do that. Okay. So one more thing I wanted to mention about variables before stopping this video, and that gets us back to the types here. And the book doesn't mention it, and it probably should. These variables that go from negative to positive have unsigned options. So if you do an unsigned int will all be positive, and it basically will be double the range on the positive side. Okay. And that's really the only thing that we're missing, I think, on the discussion of variables. Okay. So we'll continue to use variables and some examples as we go along, but that's the basics of variables.